If you want to get your metal lathe set up for gunsmithing, specifically precision rifle barrel work, there are a lot of mods you're going to want to take a look at to ensure optimal workflow, and that's what we're going to cover in this video. Hey guys, Gavin here from UltimateReloader.com. As you've seen here on the channel, we've done a ton of precision rifle barrel work here on the channel, and I absolutely love it. We've got a variety of Precision Matthews machines, starting here with the PM-1340GT. We've already published the overview video. You're going to want to check that video out if you want to know about all the dial speeds, specifications, and see the lathe in action. We also have two 1440 machines, the PM-1340GT and the PM-1440HVT2. Two different lathes, fairly similar, one geared head, so limited number of speeds. The HVT2 is a heavier machine. It has a cast iron base. It has variable speed. Then we will go all the way up to the TL1660. 16-inch swing, 60 inches between centers. A really big, massive, super solid machine, and has a giant spindle for great through spindle capacity, which is a huge benefit when it comes to doing things like threading the muzzle of a barreled action, and you need a lot of room in the spindle to get the whole thing in there so you don't have to take the barrel off, that kind of thing. Okay, so that's kind of a backgrounder. We just got the 1340 GT set up, and I just this couple days ago got finished with the entire process of getting this lathe optimally equipped for rifle barrel gunsmithing. And what I want to do is go over all of those mods in detail. Okay, so the first thing I want to talk about is something that is incredibly important and generic for all machining, and that is storage. I've equipped this 1340 GT a lot like I did the PM-1440 GT, and that's two different trays. One for the headstock. This is giant. It's massive, and that's absolutely on purpose. I've got room for things like my precision measurement tools, my dial test indicators and indicators on their magnetic bases. We've got storage for chuck keys, right where they're going to be at hand's reach, but where we can easily put them away in storage and not be tempted to leave them on the chuck, that kind of thing. And so this headstock storage area is an area where I consider my primary access to paperwork, tools, and some limited supplies like the grease that we use on the threads for the breech end and the muzzle end of the barrel itself. We've got things like thread pitch gauges where we check our thread pitch prior to commencing the threading process. We've got our oiler with weigh oil after we wipe down the weighs before we use the machine each time. I've even got storage for Allen keys, the screwdriver type Allen keys that we use with the lathe spider, which we'll talk about in just a moment. Okay, so that's the headstock tray, and then we've also got the splash guard tray, and this is full length. It goes about 3/4 of an inch beyond the splash guard, and this is where we're going to have all of our other tooling and accessories, and we even relocated the DRO up here. So the DRO with its bracket as equipped from the factory is over here on the left hand side. In fact, it was kind of right in the way where splashing oil would go from what you're machining close to the chuck on the headstock side here. So with the DRO here, this is really, really solid, and it's at arm's reach when we're working at the lathe, and it's really easy to see, and it's totally out of the way. Some other storage things. We've got a totally custom Morse taper number 3 tooling rack right above the tailstock, so really easy to jump back and forth between tools with the tailstock. Absolutely love that. Now, the lathe also has built-in storage on the headstock side and on the tailstock side. That's where I'm keeping the toolbox and chucks and other things of that nature. Okay, so I actually did quite a bit of work here on the headstock side. I want to show you the spider that I built and how that is installed and removed. So we've got a 3/16 key here. I drilled through the tray, I drilled through the side cover, And that's just going to locate right here. We've got a pinch clamp on this spider. This is perfection, right? This is my second major revision, and the big difference here is that we've got set screws here that are going to clamp our adjustment screw in place and prevent it from moving. This means we don't have to use nuts. The nuts are always in the way. You have to back them off, or you have to tighten them down depending on how you're retracting or extending your spider screw. So this has proven to be a super good design. And while I have this off, I want to talk to you about the mods that I did here to the side cover. You can see here, this is kind of how the side cover was from the factory. It had this extra bit over here. Well, what I knew was, once I got a rifle barrel installed and dialed in, I didn't want to have to disrupt anything to do a belt change. And as you saw here, you can't really do a belt change with this cover in place. That was a problem. So I put this on a chop saw, very carefully did my chop, did some other work here to get this little radius, and that means that we have free access to the belts, very easy to change. You can see we have this lever here, and if we push down on the motor, we can tension the belt, and that makes it really easy to relax the tension, do your change, apply more tension, and lock it in at that tension setting. And then as you can see here, I also had to significantly bore out the hole that goes around the outboard side of the spindle. And that gives us room for the spider to go in through. And then this is pretty amazing. With just a little bit of torque here on that pinch clamp, it is absolutely solid, and we have our tools right here. I also put this pad here, this steel pad, so that we can take one of our indicators and put it right here. And that means that when that barrel is protruding through, we can true up the outboard end. I like to true up both ends first, and then when we're about to do our chambering, we go in, or even muzzle threading, and make sure we have a 2-point dial, and that's when we're going to potentially have to angle the barrel just a little bit to get it radially and axially aligned. And because this is steel up here, this entire tray, of course, these indicator bases are very solidly magnetically held in place, which is just the way I want it, obviously. Okay, so that's kind of the headstock area. I do have room for my paperwork up here. I'm working on some additional options there to make that even better. Okay, let's go on to the carriage. There's only one mod here. This is a standoff, and so this is going to be a bump stop. If I lock the saddle in place, let's pretend that we're going to be reaming a chamber right now. The tailstock comes up. I'm going to move this a little bit here. The tailstock comes up when we initially set this in place. We bump it where it needs to be. We keep track of our Z0. If we hit this too hard, we're going to see that move a little bit, right? Now we could actually take that and put it exactly back where it was when we started, right? So this gives us a very good kind of incremental reading on how deep we're drilling or reaming, and that's based on our 0 here on our tailstock DRO. So if we go to a certain depth and back off, I pull the reamer out of the chamber that we're working on, I take a reading with a go gauge and a depth micrometer, and I know that I was at, say, 1.1 inches ream depth, and I know I need to go 20,000th more based on my measurements. I can come up again, I can get this in place, and then we know that we can just very easily add 20,000ths more to our reading on the tailstock DRO. And I just completed chambering job, landed dead on the first time I tried. So that's a really good way to do that. Okay, so the tailstock DRO itself, this is a custom design that I came up with. Pinch clamp collar here towards the end. It does allow us to eject the tooling before it bottoms out. So there's a rigid reamer holder that I built for this lathe. I've got two. I've found that with typical reamers that we use, we need 2, 7/16 minus 1/1000 of an inch, and that's going to accommodate Manson reamers. Sometimes JGS reamers are just very slightly larger than that. We want a really tight press fit on these rigid reamer holders, and I do have a video explaining how to machine these in place for absolute perfect alignment. This is 7/16 minus 2/10,000 of an inch, and this is going to work with the Alpha carbide reamers that have a 0.43725 approximately shank diameter. Okay, so the Tailstock DRO is a winner. The rigid reamer holders really do a good job of just rigidly holding the cutting tool. If you have rigid tooling and if you have rigid work together, you're going to get really, really good results. If you have floppy tooling or floppy work holding, you're definitely not going to get good surface finishes. You may not also hold super tight tolerances. Okay, so let me talk about the first chambering job I did. It was a 6GT. It was on a steel 416R stainless barrel blank. I used carbide reamer, this reamer right here, in fact, for 6GT from Alpha Munitions, Alpha Legacy reamer. And the job was just perfection. What I noted was, getting things dialed in. The pad for the indicator on the outboard end, that was a huge help. The lathe is just a great piece of equipment for this task. I'm using a very specific VNMG insert for the turning of tenons and whatnot, and with the 416R stainless, getting phenomenal surface finish. And that gives me the satisfaction when I'm doing this work that I'm looking for. And again, with the Carriage and Tailstock DRO combination, I was able to calculate where I needed to be with ream depth, hit it the first time, go was a go, no-go was a no-go, and so perfect headspace, really good surface finish inside the chamber, no chatter or run out, so I was super happy with that job. So that's it. This is my PM-1340GT. These are the essential upgrades for rifle barrel gunsmithing, and I think if you go through and you perform this type of upgrade package and enhancements package to your lathe, you'll be really, really happy. I know I was super excited about that first chambering job, and that's a part of what's coming next. That was a customer job. We're going to do a build here on the channel, and we're going to use this lathe, and we'll demonstrate what kind of results we can get at the range with the corresponding rifle and rifles that we build over time. My question for you is, what do you think of my gunsmithing lathe and the corresponding enhancements and upgrades that I've furnished on this lathe? And what do you think about the 1340GT as a gunsmithing lathe in general? Do you have one? Please share your thoughts. And if there's specifically something else that you want to see in the future related to a rifle build or this particular lathe, please drop a comment and we'll make note of that. Thank you very much for watching. That concludes this video, and that means it's time to wrap it up. I hope you enjoyed this video. If you're watching Ultimate Reloader on TV and want to take advantage of free resources, exclusives, and hot deals, just hold your camera phone up to the QR code, tap on the link, fill out the information, boom, you're getting Ultimate Reloader emails. Don't forget to like and subscribe. Also, we're on Facebook, YouTube, Rumble, where we've got unrestricted content, and Instagram. Make sure to follow us on all those channels. Ultimate Reloader also has a commercial solutions division serving law enforcement, the military, and the gun industry. We have some unique capabilities, including a comprehensive suite of recoil testing and evaluation capabilities, trigger profiling, and more. Thanks again for watching.